All right, this is the Math Models Unit 2, Lesson 5 video for probability. So probability is really talking about just like the chance that something will happen in like a random situation. So in general, the probability of something is represented as a ratio. The simplest example of this would be like flipping a coin. The chance of me flipping heads on a coin would be 1/2 because heads is one of the options out of the total possibilities. So the bottom of the fraction is always the total possible options, and the top of the fraction is what you want to happen or what you're looking for. So just to make it clear, all probability is going to be represented as a ratio. What we're going to be doing, you probably are familiar with that. What we're going to be doing is looking at different events and probability of multiple events occurring. So in probability, when multiple events occur, like let's say heads and then heads again, if I flipped a coin twice, I flipped the coin the first time, I flipped the coin the second time, what's the probability of getting heads both times? Well, when we do that, we actually multiply the probabilities because getting it twice in a row is less likely than just getting it one time. So the probability of getting heads twice in a row is actually 1 times 1 is 1, 2 times 2 is 4. That's the probability, 1/4, of getting heads twice in a row. And you can imagine that if I keep going and say 3 times or more, the probability gets smaller and smaller. So that's what you're doing in this lesson. More than that, though, they want you to understand the difference between what an independent and a dependent event are when it comes to probability. The simplest way to put it is this. Independent events are separate from each other. They have no impact on each other. So if I flip a heads on a coin one time, it has no impact on the next time I flip the coin. Even though we sometimes think it might, that if I flip heads, it's less likely the second time, it's actually not. It's still the same probability, 1/2. Dependent events they do have an effect on each other. This would be like if I'm drawing something out of without looking, like I'm going to have a bag of M&Ms and I want to take a brown, and then what's the chance of getting another brown? Well, I already took a brown out of the bag. So that means there's less browns in the bag the second time I go in. That is what we call a dependent event. The chances change after the first thing happens. So let's look at the examples they have, and let's kind of talk through how to do this. All right, here we go. Solve the problem. A 6-sided die is rolled. What is the probability of rolling a 6? Okay, I'm not going to do a lot with this one. I'm just going to tell you you need to have a fraction. The bottom of the fraction is all of the options. So in other words, how many different things can you roll on a die? The top is what you want. So again, the bottom is the total. And the top, in this case, is how many of them are a 6. So this is what we call the success. So what is the probability? How many of the options are successful options? And how many of the options are there in total? Let's go back. So the bottom is how many are there in total? How many options could you get on a 6-sided die? And how many of those options are rolling a 6? Okay. So like the flipping of a coin, it was one option, heads, out of 2 total options, heads and tails. So you should be doing this. You know what? We know there are 6 options, and we know that one of those options is a 6. 1, 2, 3, 4, 5, and then 6 is the one that we like. So this is the probability of rolling a 6 on a 6-sided die. Okay, that's pretty straightforward. Well, what happens if we have more than one event? A bag contains 10 red, 5 yellow, and 6 blue marbles. What's the probability of pulling out 1 blue marble and then 1 red marble without replacing? This indicates this is what we call dependent, because we are changing the conditions. So they're going to have 2 fractions. The first one is going to be the fraction representing drawing a blue marble, and then the one where you draw a red marble. So the question is, how many blue marbles are there, and how many total marbles are there? So blue over total, and then red over total. But remember, you've taken one out, so you need to subtract one from the total in the second draw. And I drew a plus sign here when it shouldn't have been a plus sign. It should be multiplication. You multiply the fraction of the reds times the fraction of the blues. I'm not going to do all these for you because I think you can get these. What's the probability of getting a number greater than 2 on 2 rolls of a 6-sided die both times? This is an independent event. Rolling a 2 the first time doesn't affect rolling a 2 the second time. So you have 2 fractions. You're going to multiply them. You're always going to be multiplying these fractions. What's the probability of getting a number greater than 2? So 1, 2, 3, 4, 5, and 6 are our options. So if I want to get greater than 2, I'm going to need to roll one of those. So that means there's going to be 4 out of 6. And then your second fraction should be the same. Then you multiply the answers, and you reduce the fraction, and that will get you your final answer. 4 over 6 times 4 over 6. I'm not going to do all these. I'm going to start skipping through. A fair coin is tossed 4 times. 4 fractions, each of them being multiplied by each other. Each one is the probability of rolling or of flipping a coin and getting a heads. You should be able to get that. 4 fractions, each one is a heads. Come back to number 5. A die is rolled twice. What's the probability of getting a 5 or an even number? So again, we'll write down our options. 1, 2, 3, 4, 5, 6. Well, let's see. What's the probability of rolling a 5 or an even number? So those are the options. 4 options out of 6, but you're doing it twice. So you have 2 fractions. Using the thing I just talked about here, I'll let you finish that one yourself. 1 card is drawn from a standard deck. A standard deck has 52 cards. What's the probability of getting a jack? There are 4 jacks in the deck. I'll go ahead and tell you that because you may not know that. 4 jacks in the deck. I'll let you make the fraction there. We'll come back to number 8. From 42 boys who made the team, 1 will be chosen as a kicker and 1 will be chosen as a quarterback. What's the probability of being chosen as the kicker or the quarterback? So or is a great word in probability that means to add. So we're going to have 2 fractions, and we're going to add those fractions this time. So you need to tell me what's the probability of being a quarterback and being a kicker. It says there's going to be 1 of each, and you have the total right here. So make 2 fractions, add those fractions together. 2 dice are rolled. There are 36 possible outcomes of rolling 2 dice. What's the probability of getting a total of 7 on 1 roll? So in other words, how many ways can you get 7? You can get a 7 by doing 1 and 6. You can get a 7 by doing 2 and 5. You can also get 1 by doing 6 and 1, or 5 and 2. So you need to tell me how many different ways can you make 7 between those 2 dice. There is a total of 36. So at the end, you're going to have some fraction over 36. The top of that fraction is going to be how many ways can you make 7. All right, so I think you started on most of those. Let's clear all this out. Looking at number 5, the ratio of the number of girls to the number of boys was 2 to 5. So that means that of the number of girls, there are 2 out of 7 girls, and for the boys, there are 5 out of 7 boys. Make that a little bit smaller. There. So for every 7, there's 2 girls. For every 7, there's 5 boys. If 2,450 were present, how many are boys and how many are girls? Check it out. I got 2 proportions for you. You need to solve those proportions. You should remember, but this is going to be cross multiplication. You're going to cross multiply each of these. You'll need extra paper for sure, and solve for x. The x for the first one will be the number of girls because the 2 was the girls, and the boys will be the second one. Okay. Scroll down. 210 boys are trying out for football. 20% made the team. How many were chosen? 20% as a decimal is going to be 0.20, and you need to multiply that times the total. Anytime you have a percentage problem like this, you're just multiplying the total times the percent. Total times the percent will give you the part that you're looking for. And that's it for lesson 5.